Forget every record you know. That light you see is not a galaxy. It is a matter-eater capable of swallowing every star in the Milky Way. An entity so vast that light itself takes days to traverse its circumference. Welcome to the universe's largest, ultra-massive monster. This is Nova 3, traveling at light speed toward the cosmic giant Phoenix A star. At 300,000 kilometers per second, we pass the Moon in just 1.3 seconds. Mars in 12 minutes. And Pluto in 5 hours. But as we leave our solar system, we face a terrifying reality. On this cosmic scale, even moving at light speed is like a turtle crossing a massive ocean. Reaching our nearest neighbor, Proxima Centauri, takes 4 years. Crossing the vast Milky Way takes 100,000. But our destination, the Phoenix Cluster, lies 5.8 billion light-years away. We must travel at light speed for a duration equal to half the age of the universe. During this eternal flight, Earth's oceans will completely dry up, and our sun will fade away long before we even arrive. Finally, a colossal structure emerges from the darkness, and right at the heart of this chaos, the absolute master of gravity awaits us, Phoenix A star. Before facing the monster, we must understand its home. The Phoenix Cluster is no ordinary place. Most galaxy clusters in the universe are now quiet. Their galaxies have aged and fallen silent. But this cluster takes its name from the mythological bird for a reason. It is a zone of cosmic rebirth. Immense rivers of cold gas flow toward the center, fueling the birth of thousands of new stars every year, hundreds of times the rate of our Milky Way. Yet, the force ruling this galaxy is not a creator. It is a matter-eater. At the center lies an object that renders the entire supermassive classification insufficient. Phoenix, a star. It belongs to a terrifying new class, the ultra-massive black hole. Consider Sagittarius at the center of our Milky Way. It is 4 million times the mass of the Sun, and to us, it seems huge. Phoenix, a star, however, is 100 billion times the mass of the Sun. If we could place them side by side, our galaxy's giant would look like a mere grain of dust next to this monster. $100 billion solar masses. It is easy to pronounce, but nearly impossible for the human mind to visualize. Let's make a comparison. Take the total weight of approximately 200 billion stars, plus all the planets, asteroids, and vast gas clouds in the Milky Way galaxy. Phoenix A star alone weighs as much as this entire galaxy, a single celestial body, weighing as much as billions of stars combined. So, what would happen if we took Phoenix A star and put it in place of our Sun? The event horizon, That black border from which not even light can escape would swallow Mercury, Venus, and Earth in a fraction of a second. But it wouldn't stop there. Mars, Jupiter, and Saturn would instantly vanish into the abyss. Even Neptune, the furthest planet, and Pluto would remain buried deep within the center of this darkness. In fact, even Voyager 1, traveling for 45 years, would still be trapped deep inside. With a diameter of 590 billion kilometers, this is not just an object. It is a massive abyss opened in space. To truly grasp this scale, let's use the fastest thing in the universe as our ruler: light. Light travels 300,000 kilometers per second. If you travel at light speed, you can circle the entire Earth 7.5 times in just 1 second. Now, let's apply this same speed to Phoenix A star. Imagine a spaceship skimming the event horizon at the speed of light. Seconds, minutes, or even hours. None would be enough. Despite moving at the universal speed limit, it would take you 71 days just to return to where you started. Think about it. While light conquers Earth in a fraction of a second, completing a single lap around this giant takes months. The real question keeping scientists awake is this: is the universe's history enough for such a giant to form? Standard models say black holes start small, from dying stars. They grow by eating matter. But there is a physical speed limit, the Eddington limit. If a black hole feeds too fast, it chokes on its own radiation. Phoenix A star breaks these rules. It is simply too big to have grown this way. Time wouldn't be sufficient. So, scientists propose a terrifying alternative: the direct collapse theory. At the dawn of time, before the first stars, massive primordial gas clouds didn't fragment. Instead, they collapsed entirely under their own weight. This process skipped the life of a star and directly birthed a giant seed black hole. Phoenix A star was born a monster. By devouring countless stars and merging with other black holes for billions of years, it reached its current ultra-massive form. So, how do we see a pitch-black object 5.8 billion light-years away? Black holes don't emit light, but when they feed, they become the brightest beacons in the universe. The Chandra X-ray Observatory revealed the truth. It detected massive voids in the cluster, carved out by powerful jets blasting from the black hole. These jets pushed away huge gas clouds, creating empty cavities in space. By measuring the sheer size of these voids, we calculated the terrifying scale of the engine at the center. Just as everything ends, so too must these giants. But their end lies far beyond our perception of time. Through Hawking radiation, they slowly evaporate. But Phoenix A star is so vast, its death will take not trillions, but Google years. A 1, followed by 100 zeros. When the last star fades and the cosmos plunges into eternal darkness, only these castles will remain. Phoenix A star will stand as a silent monument, asserting its existence in absolute nothingness. We have come from Earth to here. What stands before us is not just a structure, it is the ultimate limit of power, time, and matter.